So now we are going to simulate this one. This is a closed cycle or a closed loop. As you see, there is no inlet or outlet. And this is a refrigeration cycle. So for this refrigeration cycle, we have 4 items. First one is a compressor, secondly a condenser, expansion valve, and evaporator. So now we are going to simulate 4 different unit operation in Aspen HYSYS. This will be a compressor, a condenser, this is a valve, and this is a heater. Okay, so at the beginning we are starting with the compressor. The compressor function is to compress our refrigerant. So is this dashed red could be any cooler like or refrigerant like propane, ethane, maybe any type of refrigerant that it could be mixed together. So this is our material stream. Okay, after that we are going to define the fluid package, which will be in this case pink Robinson, because we are dealing with propane. After that we are going to add the unit operation. At the beginning we have a compressor, which main function is to compress our refrigerant. This stream, we are going to compress it. So this stream must be 100% vapor, because it is entering a compressor and the feed to the compressor must be in the vapor phase. After that the compressor will compress our refrigerant, and the pressure, also the temperature will be increasing. So here stream number B, here stream number A will be a low temperature, low pressure vapor. After that it will be compressed to stream number B. Stream number B will be also vapor, because the compressor only deal with vapor, but this vapor will be at high temperature and also high pressure. So this stream, because of the high temperature, will be fed to a condenser. The condenser here, the high pressure refrigerant here coming from this section will be entering this one. So the function of the condenser, in the condenser the high pressure refrigerant gas releases its heat. So here we are going to cool the stream from here. So this is a high temperature stream, this will be a low temperature stream, but at high pressure. So the pressure will not change, it will be a high pressure, but here we are lowering the temperature in this condenser. So stream number C will be in a liquid phase at low temperature and high pressure. After that we are having our expansion valve. The main function of the expansion valve is to reduce the pressure of the refrigerant, allowing it to expand and cool before entering the evaporator. So stream number C is, as we know, a high pressure liquid at low temperature. So after the expansion valve it will be a mixture of a gas and a liquid at low pressure and a low temperature. Okay, so here we have a low pressure, low temperature. The low pressure is coming because this expansion valve is responsible for reducing the pressure. Okay, how it's functioning as the opposite of the compressor. The compressor here lowers the volume, so the pressure increase. The expansion, as the name suggests, increases the volume, that's why the pressure will drop. Okay, after that we have stream number D. Our stream number D will be a low pressure, low temperature, and it might be a mixture of gas and liquid. Also it could be the composition or the quantity of or the vapor fraction could be different. Okay, like more liquid or more gas, but they are existing together, a mixture of vapor and liquid. After that we have our evaporator. The evaporator here absorbs heat from the environment. So the environment here is the system that I want to cool. Like if I want to use this cycle, refrigeration cycle, for the AC or air conditioner, so this will be my room. The evaporator here will be taking heat from my room and increasing the temperature of the refrigerant inside it. So it takes the heat from the surrounding and increase the temperature of the refrigerant or the propane inside this stream. So at the end here we will be having 100% vapor at high temperature and low pressure. That's why it's entering over right here, and the cycle will be repeated again. Okay, so if we look over here, while it's operating, the evaporator is the most important. Evaporator is taking heat from the surrounding and giving it to our refrigerant. On the other hand, if you look here at the condenser is lowering the temperature of the refrigerant. Okay, so now we are going to go to Aspen HYSYS, and we are going to start this unit by adding our material stream or the component list and the fluid package at the beginning. Okay, so now I'm going to enter over here and I'm going to create my new case. My new case will include 4 unit operations and different material string, but it's a closed loop. So as a beginning, I'm going to add here, you add any refrigerants that you are going to use. So in my case, I am going to stick with propane. Actually, propane is displayed in front of us over here, like this is the third hydrocarbon, C3. So I'm going to add it over here. So this one, we are going to rename it like this is a refrigerant. This component list contains my refrigerant. And after that, I am going to add my fluid package. In this case, we are dealing with hydrocarbon and it's in the gas phase, so Binker-Robinson will be just fine. If you are struggling, just use a method assistant and it will give you some clarity. After finishing what is needed to be added to the properties, you can now enter the simulation environment. Inside the simulation environment, we will be having our first material stream, which will be propane. In this case, instead of naming propane to compressor or propane to cooler or condenser, we are going to give it the code of 1, 2, 3, and 4, because here we are dealing with 4 stream. So at the beginning, I'm going to create the first material stream, which will be stream number 1 over here, and after that, this stream number 1 will be entering our valve. So we have 2 theories here. You can create each stream and make it converge, like now I'm going to enter this stream and fill the data, like the temperature, the pressure, or you can create the whole cycle, and after that you can enter all the data. But because we are like engineers, we are not dealing with data entry, so it will make more sense if we create our stream stream by stream. So we have 4 unit operation. Which one is coming after one? This is our final product or our final converged system. So this is stream number 1 will be fed to GT. So here we need to add the valve. After that, stream number 2, and after that we'll have a chiller. This chiller is our evaporator or our heater. Okay, this one is taking heat from the surrounding over here. Okay, so back to our simulation. After that, we have our valve added. So this one is our control valve, or you can search for the valve. Okay, so I forgot to enter the data for stream number 1. So for stream number 1, the information that is given, we are entering this valve. So remember when we were talking about the valve, what is entering the valve? It's liquid, and this liquid is at low temperature and a high pressure. So now I know that the vapor fraction of the stream entering the expansion valve is 0 because it's totally liquid. So back to our simulation, and okay, I'm going to delete the valve because it would be right now confusing. So this stream which is entering the valve, I know it will be in the liquid phase, so it's unknown. The vapor fraction would be equal to 0. Also, I'm given the temperature to be 50 degrees Celsius. Okay, so I'm dealing with SI units, just to be careful. Here we are asked about the composition, so we can go to the composition and make sure that the composition is 100% propane. If we have a mixed refrigerant, we can define each refrigerant composition, okay, like mole percent. After that, we have defined, currently we don't have information about the flow rate, But what is important to know about Aspen HYSYS is that they offer a back calculation. By back calculation, I can define the exit information or the downstream information, and they can do back calculation and calculate the upstream information. So till now, this is all the information that I have for stream number 1. And moving forward, by adding other unit operation and other material stream, you will find that they can back calculate all the information that was missed in stream number 1.